Your agent's message list can't answer this question, but RAG can. Welcome to AI Agents in Depth, Episode 3, Agent Memory and RAG. You'll build chunk, embed, and retrieve, then prove it works with a green oracle test. Last episode, the agent kept context as a growing list of messages. This episode, it learns to fetch facts it was never given at all. First, we read the map, the book's chapter, and a hand-drawn diagram. Then we build each piece. Then we prove it with a test. First, the source of truth. Open Chapter 3. It's already in the workspace, no download. This is Boji, Lies AI Agents in Depth, the book driving this series. Chapter 3, Section 3. 2 labels at retriever plus generator. 2 components share no weights, only text passes. Section 3. 2 names 2 parts. A retriever that picks passages, a generator that answers with them. The knowledge base, KB, is the store it searches. Recall rate is the fraction of right answers the retriever can even find. Miss the passage, no model fixes it. The retriever is the hard ceiling. Section 3, 2 says so. Here's the pipeline, drawn by hand, in Excalidraw. 3 arrows first, watch the cursor, 1 at a time. Arrow 1, chunk splits the document into short passages. Arrow 2, embed turns each passage into a stored vector. Arrow 3, your question embeds with the same vocabulary. Arrow 4, cosine rank keeps the closest chunks. Arrow 5, they inject as a tool message after the system prompt. Now trace all 5 yourself. That keeps the KV cache prefix valid. The model reads the chunks. Its weights, fixed at training, never change. That's the whole pipeline. 2 components, 1 text interface, no magic. EP1 and EP2 code is already an agent, Pi. We're appending RAG code below it, never retyping what's already written. There's the existing agent. We only append, never redeclare. The EP3 marker we're about to add keeps the diff clean. Chunk splits a document into independently readable passages. We split on period space, not a fixed character count. Fixed character counts cut mid-sentence. Those fragments embed poorly. Sentence boundaries keep each chunk independently readable. Too small loses context. Too large dilutes the signal. Let's see chunk slice a real 3-fact document right now. Three strings. Each is independently retrievable. The if-s, strip, filter prevents phantom empty chunks from trailing periods. Plain strings, 1 per fact. Now embed maps an entire chunk to 1 vector. It lowercases, splits on whitespace, then counts vocab word occurrences. Build vocab indexes all chunks before any query and stores the result in KB vocab. Embed uses an explicit vocab when you pass one, or falls back to that stored vocab, so retrieve can call it without threading vocab through manually. No network, no API key. Swap this body for a real model in one line. Your turn. A missing vocab word just scores 0. Run this and see. Two integer lists. Eiffel scores 0 in the first, absent from that query. Absent tokens get 0, correct behavior, not an error. Different inputs, different profiles. Picture 2, arrows from the same point. Tiny angle, similar vectors. Big angle, completely different. That's all cosine similarity is. Same topic, similar direction. Pure geometry, not a neural network. Better embeddings make better arrows. The angle math already works on our word counts. Without normalization, longer chunks score higher by size. The formula: divide dot product by magnitude A times magnitude B. The else is the 0 vector guard. Unknown tokens give magnitude 0. 0 dividing crashes. Return the 0 vector instead. Normalize first, and the dot product equals cosine directly. Now retrieve. 4 moves. Build vocab from chunks, embed the query, score each chunk by dot product, return top strings. Returns strings, not indices. Dispatcher appends them as the message, same as word count. RAG for shared knowledge. A session dict like user memory handles per user facts. Run it now. 2 chunks, one about Paris, one about a tower. Ask about the capital. Paris is the capital comes back. Capital overlaps the query, and that chunk, highest dot product, wins. The retriever's quality is the hard ceiling on every answer. Your turn. Change capital to tower and run it. Tower is tall comes back. Adding to tools is the complete change. 0 loop edits needed. Retrieved chunks vanish after each turn. The next turn starts fresh. Tools is a dictionary. Add 1 key and you've added a tool. The loop never needs touching. Tools holds every capability the loop can call. Conversation and parse actions stay exactly as EP2 left them, open for extension, closed for modification. KB chunks plants our oracle fact. KB retrieve is the cosine retriever. 2 lines wire it into the agent. KB retrieve builds vocab from KB chunks, scores each chunk by cosine similarity, and returns the best match. Tool descriptions extends for the real LLM swap. Top K is baked as 1 here. Production uses 3.5. Now test agent. Pi, a new stub that forces exactly 1 retrieve call, then echoes whatever the tool returned. Fake LLM RAG drives retrieve, while fake LLM handles word count. No tool result yet. It calls retrieve. Tool result exists. It echoes it as the final answer. Retrieval is mechanically required. It can't skip it. Zeta 7 appears nowhere in fake LLM. Pi. This test can only pass if retrieve. Return the right chunk. Fake LLM RAG echoes whatever the tool returned. If retrieve found the Zeta 7 chunk, it passes. If it didn't, no model capability can fix it. That's the retriever ceiling principle from Chapter 3. Your turn. After this green run, comment out KB chunks in agent. Pi and run pytest again. Watch test RAG retrieval fail. All 4 tests green. Pause here. Comment out KB chunks. Rerun pytest. Watch test RAG retrieval fail. That failure proves Zeta 7 lives in the KB, not the model's parameters. You chunked a raw document into passages, built a deterministic bag of words embed, ranked chunks by cosine similarity, and wired retrieve as an agent tool. The Oracle test made it undeniable. Without retrieval, Zeta 7 is unreachable. Pause here and try this. Add a second fact to KB chunks. The launch date is March 5. Write a second Oracle test in test agent. Pi that asks the agent what is the launch date, using fake LLM RAG, and run Python pytest q. All 3 tests should be green. Quick check. What delimiter does chunk? Used to split a document into passages. A period followed by a space, dot, then space. So each sentence stays independently readable, and its embedding represents one focused idea. Second question. When retrieve returns a chunk, where does that text appear in the agent's message list? As a role tool message, the exact same slot word counts result occupies. So the LLM reads the retrieved passage in its context window before it generates the final answer. Next up, Episode 4, Tools and MCP, giving the agent hands. Follow so you don't miss it.